Hello students, good morning. Today in this video we will study about Einstein's photoelectric equation more elaborately. In the previous video I introduced photoelectric emission. Now what is photoelectric emission? Okay, the word itself very clearly suggests that electrons, photo, light, by incidenting light of sufficient frequency. Now I go to the next stage of it. See, if I take a metal and allow light to fall on it, and every metal for every type of light of frequency gives out electrons, it is not possible. It is a very specific phenomenon where light should have sufficient frequency, and that depends on the nature of the emitter metal which we are taking. And this photo electrons being emitted when subjected to light from a metal, that is called photoelectric emission. So it's very simple phenomenon, emission of electrons when a metal is subjected to are exposed to light, but light of sufficient frequency. So let us see here in a very simple terms, we have got a metal, right? Let us say alkaline metals like sodium, potassium, they have more tendency to give out with ultraviolet radiation. So ultraviolet radiation is also in the electromagnetic spectrum, ultraviolet, visible, infrared. So some of them will have tendency to give out light at a particular frequency. Now when I take a metal here and allow light to fall on it, yesterday I said to you about photo equation. What is the basic concept of photon or quanta? Max Planck's theory. Okay, Planck's quantum theory. According to Planck's quantum theory, the light is made up of quanta or photon. You can call these light particles as photons. Now what is the energy possessed by the photon? That energy is equal to h nu, where nu is the frequency and h is called Planck's constant. It is called Planck's constant. Okay, its value is 6.63 into 10 power minus 34 joule second. This you can learn, it's a constant, you need not memorize this, right? It will be given to you in the examination. But what is the concept? The energy of the photon is h nu, where nu is the frequency. So when light of sufficient frequency falls on a metal, the metal is having the electrons in the outermost shell, and the electron comes out first. Okay, the energy required to remove the electron from metal is called work function. Okay, work function is the minimum energy required to remove an electron from a metal. Now this electron need not stay on the metal. If it has sufficient energy, it will move forward, and that is what we call it as electric. Electric means what? Movement of electron, right? The electron will move and it will possess kinetic energy, and we call it as kinetic energy maximum. So based on this, we have the Einstein's photoelectric equation, which says that the incident energy h nu is equal to kinetic energy maximum plus the work function W naught. Okay, with this idea in our mind, okay, we can write what is work function. Work function is again energy. Energy using Planck's quantum theory is h nu. But what is this work function? Minimum energy. So it requires minimum frequency. So I will put a nu naught, and nu naught is called threshold frequency. Threshold frequency is the minimum frequency required for the electron to be ejected or emitted from the metal. So let us be clear about two things here. One is incident photon has an energy and it is used for two purposes. One is to remove the electron and another is to provide sufficient velocity and hence the kinetic energy. So this is the formula. If I wanted to modify little, I can say H nu is equal to kinetic energy maximum plus H nu naught. I can put it as H nu naught. That's also one way of expressing. Fine. Let us move from here to the concept based on experimental verification, right? We need to experimentally verify all these things, yeah, and that is the next point which we are going to study. Now, how do you verify experimentally? This is experimental verification, experimental setup, let me write it, okay, to verify photoelectric emission. What it consists of? It consists of a phototube. A phototube is a evacuated glass tube with a narrow window for light to fall, and it's very simple, right? This is the phototube. So let me draw a little bit more better. Yeah, okay, yes. It has got a electrode here on which the photons are going to incident. The energy of the photon is h nu, and we know this, right? The minimum energy without which it cannot emit the electrons. And let me connect this to a battery. The real circuit is more complex, but I am going to simplify for you to understand the concept. So I am going to connect this to negative. So let us call it as electrode 1, or you want to call it as cathode, let us say, and naturally the other side we have got anode. But I would like to simply call plate P and plate Q for a simple reason. I will tell you later. Right. P and Q are the two electrodes I got, and now I've got a galvanometer or ammeter. I can connect it, and this is the connection, negative and positive. Now ammeter will measure the current. The ammeter will measure the current. Now you are subjecting it to the photon. You are subjecting this into the photon. Now the energy is there and electrons are ejected. Electrons are ejected. So the electrons will move because this plate being positive, plate Q being positive, electron being negative, it will be attracted towards the positive plate. Yes, you got this now? It will be attracted. The more and more the electrons are coming, the more and more the plate will attract, and hence the ammeter, it will show the deflection, and we know that current is coming. Fine, this is the normal structure where we are having the formula, the H nu is equal to W naught, which is the work function, plus kinetic energy maximum, the energy of the electron, which is going to be maximum. I am going to put Y, that is maximum. Now what I am going to do, I am going to make the plate Q less positive. Let me say if this was 5 volt, I will make it as 2 volt. That means I am making it less positive. When I make it less positive, what will happen? This is electron negative and this is positive, but less positive. When it is less positive, the attraction will be less. This is not going to attract. Now this is not going to attract. The electron has to use energy. The energy of the electron should be more. The energy of the electron should be more, and then only it can reach the Q, the electrode Q. You get my point? Now, if the electron has more energy, then it reaches the plate. Now, I make it now as negative potential. Let me say I make it minus 3 volt. Now, don't worry about this is negative and this is negative. Do not worry about it. little bit complex key is there, which I am not going to use it, reversible key, I am not using it. Think of it, just I make this more and more negative. Now, less positive I made it, and I am now coming to 0. I come to 0 potential, and then I go to negative. When it goes to negative, see, electron is negative, and the plate also turned negative, then what will happen? If both of them are negative, there will be a repulsive force. If there is a repulsive force, the electrons cannot reach there. If the electrons doesn't reach there, there is no photoelectric current here. Okay? Then who can reach? Only the photon which has maximum kinetic energy can reach. That means the kinetic energy of the electron should be maximum for it to reach. Now, if it is not maximum, what will happen? It will bounce, it will return back like this, right? The maximum kinetic energy, it tries to reach here, right? At that potential where the electron is having maximum kinetic energy to reach, and that potential is called stopping potential. What is that called? That's called stopping potential. I hope you get my point. Now, the energy is maximum, kinetic energy is maximum, and the electron is now stopped here and is going to come back. At that time, think gravitational force, right? Now, this is there, the electron is trying to come and it is coming back. That means, imagine in terms of gravitation. Now, this is there, I am throwing the chalk piece up. At a particular point, it momentarily stops and comes back. So, what is the energy it possesses at the highest point? That is potential energy. And here it has got electrostatic potential energy. Now, the energy is called EV naught. Now, what is V naught? V naught is stopping potential. Stopping potential is the negative electrode potential which stops the electron from reaching the electrode. Fine. At that time, you will find that kinetic energy maximum is equal to EV naught. That is, kinetic energy is equal to potential energy. Okay, so this is a very important relationship which we should understand. I hope you get my point. This, do not worry about this being negative and this being positive. It is a starting point. Yeah, and what I do, I make it negative, positive, less positive, make it 0 and bring it to negative potential. At that negative potential, the plate Q will repel, and the electron with the maximum kinetic energy will try to reach there, and that point, that energy is equal to the electrostatic potential energy, and that is the equation which I have got. So I can write this equation, Einstein's photoelectric equation, as h nu is equal to W naught plus, instead of kinetic energy, I can put potential energy as EV naught. I can put it as EV naught. So we can make small changes. In the same equation, I can write h nu is equal to h nu naught plus kinetic energy maximum, and I can write here h nu is equal to h nu naught plus EV naught. I can write like this. We can make more equations from this, and in the next video we will do basically a graphical representation using photoelectric equation of Einstein. And this is a very interesting concept, and I said to you in the previous video, for which Albert Einstein, the great genius, was awarded Nobel Prize. If I am not wrong, it is 1920 or 1919, check it out, right? And this is the experimental verification, and this is called a phototube. It just got 2 electrodes, and there is a window, and it is evacuated inside. No air is inside. No collision can take place with any other atom. So it is a very clear process. and this is a reversible key will be there, more complex diagram will be there, that you don't worry, understand the concept. So H nu is equal to Ke max plus W naught, or H nu is equal to EV naught plus W naught, where work function is W naught, and the minimum energy required to remove the electron is called threshold frequency. Okay, next video we will learn more. Thank you so much.